Thanks everybody for sticking it. Yeah, you're right. It's hard to hear up here. Thanks everybody for sticking it out till the end. I am going to be telling you guys about an ocean voyage. We can advance. I'm Peter Selkin in science and math. Contrary to what it says up here, I play with magnets. We can go ahead. So the prologue to our story starts in the Himalaya, the Earth's highest mountain range. What a lot of people don't appreciate about the Himalaya is that they are also, in addition to being the highest mountain range, Earth's greatest mud producers. That mud flows down a bunch of rivers, the Ganges and the Brahmaputra here, down from the Himalayas out into the Indian Ocean through the Bay of Bengal, and along with it carries a whole lot of organic material, plant material that's ground up and essentially takes carbon from the atmosphere and puts it into the oceans. The Himalaya are responsible for about 10 to 20% of that carbon that goes from the land to the oceans. And so they have a huge negative carbon footprint. As a geoscientist interested in the history of Earth, I want to know how long they've been doing that and how that has changed through geologic time. Unfortunately, the geologic record of that is really hard to get to because it's under the ocean. If the Himalaya are the world's biggest mud producers, this is the world's biggest mud pie in the Bengal fan in the Bay of Bengal, which is circled here. It's very hard to access, but in 2015, along with some new ocean drill sampling technology, I participated in the International Ocean Discovery Program's voyage to the Bengal fan. That's our ship there on the right. The cruise left Singapore and ended up in Sri Lanka. We collected 7 cores, one of which was about 1.5 kilometers deep, so a lot of drilling. This is the hole in the bottom of the ship through which the drill went to the bottom of the ocean. So it went through a couple of miles of ocean before going through a couple of miles of sediment. Yes, the boat had a hole in it. My colleague Yanni Nyman bringing one of the cores off of the core deck. The coring itself was not without its challenges. The holes would often cave in on themselves, and so it was hard to get sediment into it. Our drill melted several times because sand and mud combined makes it very difficult to recover stuff. But recover stuff we did. This is kind of what it looked like. A whole bunch of sets of silt and sand and mud. These are deposits that geologists call turbidites. They're deposited essentially instantaneously in submarine gravity flows where a storm or an earthquake might trigger a big flow of mud. My job on the ship was to figure out the age of these things based on magnetic particles like this one. We looked for reversals of Earth's magnetic field captured in the magnetic record of these sediments. This is my colleague Jairo Savian from Brazil and myself up here trying to match these magnetic reversals to an established timescale. That was pretty difficult because the sediments were only deposited once every so often, so there were a lot of gaps in the record. So our paleontologist colleagues, this was a very multidisciplinary cruise, our paleontologist colleagues looked at fossils to try to figure out when, give us a time to narrow down for these sediments. Here's one of the particularly cantankerous paleontologists shaking hands with one of the chief scientists. He figured out that the fossils actually moved around in the cores while the coring was happening because they would kind of fall into places, so he was very good at picking those out. It was also difficult to figure out where the sediments were from. So here's a whole bunch of sedimentologists describing the cores and trying to come to a mutual understanding of where the sediments were from, what they represented. But eventually we got to things like this. This is the oldest mud recovered from the Himalaya, 30 million years old. And indeed it has lots of those plant fragments that you can use to track the history of carbon from the Himalaya. This wouldn't have been possible without a 130-person science staff and crew, scientists from all different countries, from Nepal, India, South Korea, Japan, and without a number of UWT undergraduates who have been working on the project since, and allowing us to move forward from just figuring out how old these sediments are to the nuances of where the sediments came from, how they're being deposited, and how quickly they were moved from the mountains to the fan. So I'll conclude here. To move forward on big science questions, it takes a lot of effort, a lot of collaboration from international teams and interdisciplinary teams.